Hi everybody, this is Mrs. Leong and I'm going to teach you guys lesson 7.3, logarithms and logarithmic functions. All right, so this might be the first time for some of you for seeing a log, so let me go and explain what this actually means. So I'll give you an easy example first. For example, if I have log base 2 of 8, what that means is, 2 to what exponent is 8? All right, so a log is always asking what exponent. All right, and so hopefully you are thinking of the number 3. So there you go, you did your first log. So if you're trying to find log base 2 of 8, that means 2 to what exponent gets you 8? And that answer is 3. All right, let's go ahead and just kind of get used to this a little bit. So we are going to write each equation in exponential form. So this is logarithmic form. We're just going to re-express it into exponential form. Just like how you can have a decimal rewritten as a fraction, right? But those are equivalent. We can go ahead and rewrite this log equation into an exponential equation that is equivalent. All right, so here we have the base of the log. I would just say keep the base, right? So this is going to be 6 to the third power is equal to 216. All right, so these are equivalent statements. This is just in log form. This is in exponential form. As you can see, you keep the base of the log, still the base for the exponent, and then just the inputs and outputs switch. In fact, these are inverse functions. So the inputs and outputs get exchanged. All right, so that is exponential form. Okay, let me show you a few more. Number 2. All right, this is going to be 2 to the 6th power is equal to 64. All right, and that's the exponential form. Number 3, same thing. We got 3 to the power of -4 is what gets you the 1/81. All right, why don't you guys go ahead and pause the video, try out 4, 5, and 6, and then unpause when you're ready to check. All right, here are the answers for 4, 5, and 6. Go ahead and check and see if you got the same. So number 4, number 5, and number 6. All right, so that is how you go from log form to exponential form. Okay, let's go to the other way for 7 through 12. We're going to go from exponential to logarithmic form. So going the other way, we got log base 5 of 125 is equal to the exponent of 3. All right, so that's what that looks like in log form. Okay, log base 7 of 1 is equal to 0 for number 8. Log base 3 of 81 is equal to the exponent 4. All right, and that is how you get it into log form. Why don't you go ahead and try 10 through 12 and then unpause the video once you're ready to check. All right, hopefully you've done 10 through 12 and now you can check. So number 10 looks like that. 11 and 12. Okay, hopefully now you guys are comfortable with going from exponential form to logarithmic form and vice versa. Let's go ahead and now evaluate some logs. Here we go. All right, evaluate each expression. Number 13, log base 3 of 81. It just means 3 to what exponent gets you 81? And hopefully you are thinking the answer is 4. All right, so 3 to the 4th power is what gets you 81. Okay, number 14, 10 to what power, to what exponent gets you 0.0001. If it helps, you can go ahead and rewrite that into a fraction, and that gets you 4. Negative to get that reciprocal, and the 4 to get you the 10,000. All right, number 15. We got 2 to what exponent gets you 1 over 16? So again, to get the reciprocal, you need a negative there. And to get to the 16, you got 2 to the 4th. So negative 4 is what gets you there. And again, if it helps, you can rewrite that in exponential form to kind of mentally do a check. And you're like, okay, yeah, that's right. Okay, number 16, we got 1/3 in the base. So to get that to flip to just 3, I'm going to have a negative in the exponent. And then 3 is what will get me the 27. All right. So again, if it helps, you can double check that with yourself on the side like that. Okay. All right, number 17. 9 to what exponent gets you 1? And that one's an easy one. You just get 0 there. Okay, 8. 8 to what power gets you 4? That one's a little bit of a head scratcher. And if you want, you can even set an equation up in exponential form to kind of help you figure that out. You're like, 8 to what power gets you 4? Well, let's go ahead and get that common base here to help us out. And we get 3x is equal to 2 once we get that common base. So we get 2 over 3. All right. And if you want to do that in your head, feel free. But if you kind of want to be thorough and make sure, again, that's the work you can show. All right, why don't you go ahead and try 19 and 20. Once you are done, unpause the video and check. All right, hopefully you guys tried number 19 and 20. Here are the answers. Number 19 was -2, and number 20 was just 4. Hopefully you didn't actually multiply that out. All right, 6 to what power gets you 6 to the 4th? Well, 4. All right, let's go ahead and flip on over to the back, and we're going to graph these log functions and see what they look like. All right, so before we get into these logs, let me go to the side here and give you an idea of what the parent function looks like. All right, what a basic log function looks like. All right, so if I look at the parent function, in fact, let's go to the parent function of our exponential function, 2 to the x, okay? Let's start with something we know. When we plug in, let's say -1, I get 1/2, 0, 1, 1, 2, 2, 4, etc. And then we would get a sketch of this graph that looks something like this. And it has an asymptote, horizontal asymptote there at y is equal to 0. Domain is all real numbers. Range is y is greater than 0. Okay, now our log function is going to be the inverse of this graph. All right, so let me go ahead and move this over just a bit to make room. For my inverse function, this is going to be y is equal to log base 2 of x. And because they're inverses, my x's and y's are going to switch. So where I had -1, 1/2, I have 1/2 -1. I'll have 1, 0, 2, 1, 4, 2. And so my graph is going to end up looking like this. -1/2 or 1/2 -1. Get me right around here. 1, 0, 2, 1, and then 4, 2. All right, so that's what your inverse graph is going to look like. That's the log graph. Your domain is going to be x is greater than 0. All right. So that comes from the range of the original function. And your range is going to be all real numbers, which is the domain of your original. All right, so this is in general what your log graph is going to look like. And this one, actually, you do have a vertical asymptote right there at x is equal to 0. Okay, so let's go ahead and play around with this graph, and let's add some transformations. All right, so for 21, this one, I do notice I have a shift to the right, 2. All right, so my vertical asymptote is going to be now at 2. And let's go ahead and plot some points here just to see what this looks like. All right, so at 2, I have a vertical asymptote. If I plug in 3, I get log base 2 of 1, which is 0. Right? And then if I plug in 4, I get log base 2 of 2, which is 1. All right, and so we get our graph approaching the asymptote, going out that way. Okay, doesn't ask for domain and range, but just in case you're curious, the domain would be x is greater than 2, and the range would be all real numbers. All right, that's 21. 22. This one, I have a dilation and I have a reflection. All right, so let's see what this one is going to end up looking like. Okay, I noticed no shifts, so I'll still have my vertical asymptote right on that y-axis. And then we can plug in some numbers here to kind of see what this graph is going to look like. If I plug in 1, right, this is going to be negative 2 times 0, which is 0, right? Because 4 to what exponent gets you 1? That would be 0. So I get 1, 0. Let's plug in a nice number here. Let's plug in 4. That would be easy to do. A log base 4 of 4. Log base 4 of 4 is just 1. So I get 4, negative 2. All right, so then we get our graph actually flipping, going this way. All right, and hopefully that doesn't surprise us because we saw that negative. We knew it was going to reflect over the x-axis. And again, if you wanted to do the domain, you don't have to. The directions don't say, but in case you're curious, the domain and range would be those. All right, so that's what a log graph looks like. Okay, so my, I guess, advice would be kind of know where your asymptote is based off of, whether or not there's a horizontal shift. And then based off of that, you can plug in nice numbers that will give you nice logs, right? So look at the base, make this 1 and then make this like 2 to the first, 2 to the second, etc. So plug in nice numbers for yourself to plot some points to get an idea of the graph. Okay. All right, let's try a word problem. Here we go. An equation for loudness in decibels is such where R is the relative intensity of the sound. Sounds that reach levels of 120 decibels or more are painful to humans. What is the relative intensity of 120 decibels? All right, so they give us this equation. All right, R is the relative intensity, okay, and then L is the loudness, right, of decibels. Okay, so let's plug in what we know. So they want to know the relative intensity. So R is what you're looking for when L is 120. All right, so plug in 120. And let's solve for R. I would go ahead and divide 10 on both sides first to kind of isolate the log. And let's rewrite that in terms of exponential form. All right, so 10 to the power of 12 is what R is. So don't worry about writing all the zeros. I'm just going to keep it in that form. Decibels, not decimals. There we go. Final answer. All right, that is it for this lesson. Good luck.